Hello there. In this video we're going to discuss the sums, difference, and products of functions. These are typically denoted as f plus g of x, f minus g of x, and fg of x. We're going to be discussing the quotients of functions in another video in more detail, so in this video we'll just be focusing on these three. Alright, so to begin, let us define what f plus g, f minus g, and fg of x are equal to by definition. So f plus g of x is going to be defined to be equal to the function such that f of x plus g of x is the sum of these two functions. Similarly, this is going to be f of x minus g of x, and this is going to be f of x multiplied by g of x. In terms of understanding of what these things are, it's nothing really difficult. It's just getting used to what this notation represents. And then you can plug in numbers for x and evaluate functions and so on. And I'll do some examples for that. So as our first example, let us assume we have f of x to be equal to 3x squared minus 5x. And let's assume that we have another function g of x, which is equal to x plus 5. So let's define some things. All right, so let's calculate f plus g first. So f plus g of x is going to be the sum of these two functions. So this is going to be 3x squared minus 5x plus x plus 5. And then we can combine like terms, as we usually do. So this is going to be equal to 3x squared minus 4x plus 5. So similarly, we can have f minus g of x. So this is going to be 3x squared minus 5x minus x plus 5. It's important to use parentheses here when you plug into these functions so you don't accidentally miss this distribution of this minus sign. This is going to be 3x squared minus 5x minus x minus 5. And then we can combine like terms as we usually do. So this will be 3x squared minus 6x minus 5. And fg of x will be equal to 3x squared minus 5x multiplied by x plus 5. From here we can distribute. So this is going to be equal to 3x cubed plus 15x squared minus 5x squared minus 25x. Combine like terms as normal. So this is going to be equal to 3x cubed plus 10x squared minus 25x. And we can say evaluate this. So we can say what is fg evaluated at minus 1. So this is going to be equal to 3 times minus 1 cubed plus 10 times minus 1 squared minus 25 times minus 1. So that's just going to be equal to minus 3 plus 10 plus 25, which is the same as 35 minus 3, which is 32. And that's the basics of calculating the sum, difference, and product of functions. So let's talk about a couple common terms that are related to these things. The first is a monomial. So a monomial usually takes a couple forms, such as 3x to the 5th, negative 4x cubed, 2x, or just 5. So a monomial is just what we call one term. So it's just a product of coefficients and variable terms. So these are the coefficients. Then we have the variable term, x. So this is sort of like x to the 0. And then we have exponents. Now we do have a rule on to classify these as monomials or not. Namely, these numbers must be natural numbers. So you can't have fractions that don't simplify to natural numbers. Same thing goes with decimals and weird other things. So an extension of this is a binomial, which is just a sum and or difference, or sum or difference of monomials. So it can have something like 3x cubed minus 5x squared, or negative 5x to the 7th minus 10x to the 11th. So again, these are two terms, 1, 2, 1, 2, and it has coefficients, 3, negative 5, negative 5, negative 10, and exponents that must be natural numbers, which all of them are. So each of these are binomials. And to extend this further, we have what we call trinomials, which has three terms, such as 5x to the 7th minus 3x to the 5th minus 2x squared. So again, they have coefficients, 5, -3, -2. They have the variable terms, x, and you can also have y in here. That's perfectly fine. You can have, say, y to the 7th tacked on there. No big deal. As long as it's a product, there's no big deal. And also the exponents have to be natural numbers. Therefore, this is a trinomial. Anything higher, we usually just refer to it as a polynomial. So, for example, you can have 3x to the 5th minus 2x to the 4th plus 5x cubed minus 2x squared plus 5x minus 7. So this will be an example of a polynomial because it's just the sum or difference of monomials where all of the exponents are natural numbers. So the term that has the highest exponent is what we call the leading term. So the leading term contains the highest exponent. So the number 3 is sometimes referred to as the leading coefficient. And the number 5, the highest exponent, is sometimes referred to as the degree of the polynomial. And these two things are going to be important when we actually discuss polynomials in more detail. So in general, polynomials can be expressed in a more general way. So polynomial. So we can rewrite a polynomial, say, function, since that's pretty much what we're talking about here. So we can call it, say, p of x is going to be equal to an times x to the n plus an minus 1 times x to n minus 1 all the way down to, say, a1x plus a0. So a0 is the constant term. So these are all of my terms in the middle. This is going to be my leading term. This is going to be my leading coefficient. And this is going to be my degree. And we're assuming that these numbers in front, we're assuming an is a sequence of real numbers and the number n is a natural number. Sometimes you may see this represented in summation notation. So we can rewrite this as the sum from k is equal to 0 to n of ak times x to the k. So this is the same as a0 plus a1x plus a2x squared all the way up to the last term, an xn, which is the same thing, just written backwards. But we're going to be focusing on summation notation a little bit later, so in case you're not familiar with this notation, we can discuss it at a later time. But for right now, at least notice this is pretty much the same exact thing, just a shorter way of writing it. So a couple things to be said about the sum, difference, and products of polynomials and some properties associated with them are the following. So here's just a couple theorems that you should know ahead of time. So let's assume that P is a polynomial function. So it's a sum of monomials, whose powers are natural numbers, of course. Leading coefficients, let's assume, are real numbers. Then the domain of P is the set of all real numbers. So if you were to graph polynomials, then you won't have any holes or breaks or anything like that. It's just a smooth curve. We'll talk about smoothness later, but this is one of the properties of polynomials, is that the domain is all real numbers. And we're not going to prove that, but we'll come back to this later and explain it in more detail. So if p of x and q of x are polynomial functions, then the following are also polynomial functions. So 1, 2, and 3. So p plus q of x p minus q of x, and pq of x. All of these are also polynomials. So if you were to add, subtract, or multiply any polynomials together, you will always get a polynomial back. Division of polynomials is not always a polynomial, which is why we're going to come back and discuss this at another time. So a couple other things that I just want to mention that is going to be extremely useful in the future is the following example. So suppose that a and b are real numbers, and f and g are polynomials. And let's assume these polynomials have the property that f of a is equal to g of b is equal to 0. So if this is true by the zero factor theorem, then we know that f of x can be represented as x minus a times p of x, and g of x can be represented as x minus b times q of x for some polynomials p and q. So an extension of this is the following. So that means f of x times g of x, which is the same thing as writing fg of x. This is going to be equal to x minus a times x minus b times p of x times q of x. So from this we can have the following conclusion. That means the product function fg of x has x-intercepts at both x equals a and x equals b, because fg of a equals fg of b is equal to 0. And you can easily observe that because when you plug in a or b into these two things, their product times the rest of it is always going to be equal to 0. So this is just some basic properties associated to the sum, difference, and product of functions, in particular polynomial functions as well, but the sum, difference, and products of any type of function will have their own special properties. When we finish talking about each of the individual families, we'll start to talk about what happens when you start to combine different families using these operations. Hope you enjoyed.